All right, so take a look at the graph that we have up there on the board. First thing, what did I say is the very first thing I need you to do before you start answering questions?
Find out what kind of graph it is.
Yeah, what kind of graph is this? So look at your y-axis. What kind of graph is this? What's delta x? Yeah, this is a position versus time graph. Delta x tells me my position, right? So I know that my slope on a graph like this is going to be rise over run, which is delta x over time, which is velocity. Good. If this was a distance time, my slope would be speed. If this was velocity time, my slope would be acceleration. Good. All right, so a couple things as we take a look at this graph. What I want you to note, what are some things that you think are important when we look at this graph? What would you say is important to know? What do you think? What does this tell me here?
Where you start, right?
Yeah, there's my starting point. What does this tell me?
Where you end.
There's my ending point, okay? And then each point represents a different time interval. And so I want to kind of take this one chunk at a time. So I don't necessarily have to memorize everything about it right away, but I just want to say, okay, well, from time 0 to time 10, what does that mean? So from time 0 to time 10, I have a positive slope, right? Which means this is a positive velocity. So am I moving towards start or away from start? Yeah, I'm going away from start. Am I going away from start at a constant velocity? Yeah, because it's a linear line. Even though my line looks horrible, we're still going at a constant velocity. So I'm just going to put CV there, constant velocity. What is my velocity at that point from 0 to 10 seconds? Okay, so I'm asking you just to solve for slope. So I rose how much? 15 meters, and then I ran how much? All right, so help me out. What is a positive 15 divided by 10? All right, my fraction, people. Don't give me 3/2. I don't want it. No. Stop giving me fractions. Nobody likes fractions. Who really likes fractions? Nobody likes fractions. Nobody likes fractions. So 1.5 meters per second. Okay. All right, then let's look. Well, what about here? 10 seconds to 15 seconds. What's their position here? Yeah, I'm at position 15, and then 5 seconds later, I'm still at position 15. So the slope of a horizontal line is 0. So I know that they are just standing still. Good. Then let me change colors. Right here, marked it in green, I have 15, and then down here at the end, I have a negative slope, right? So I have a negative velocity, which means I'm going where? Good, I'm going towards start. Okay. Can you calculate your velocity? Okay. How much did I fall? Okay. How much did I run? 5 seconds, right? So negative 15 divided by 5 is going to give me a negative 3 meters per second. Okay. Now, this is a linear line, right? It's a straight line. Sorry, that was even worse. Yes. So that means I'm moving at a constant velocity. So am I accelerating?
No.
From time 15 to 20? No. But at time 10, did I accelerate?
No.
At time 10. I was going 1.5. Now I'm going 0. Did I accelerate? Yes.
Oh, yeah.
At time 15, I was at 0 meters per second. Now I'm at negative 3 meters per second. Did I accelerate? Yeah, I did. Okay? So when I'm looking at this and I say, okay, well, how would I then translate this to a velocity time graph? How would I translate this to a velocity time graph? Do I have my velocity for all those points? Yeah, I do. Okay, so let me go ahead and add a velocity time really quick. Okay, so we have 0, we have positive velocity up top, negative velocity down below, time. We know on this one our slope is acceleration, right? All right, so from 0 to 10 seconds, what's my velocity? Close. Try it again. Good. Okay, so I'm going to come up here, and for those first 10 seconds, I was going positive 1.5 meters per second. Okay. From 10 to 15 seconds, what did they do again? They stood there. So now my velocity during that time period is 0. So I'm going to make it as dark as I can there. Okay. And then from 15 to 20, my velocity was what again? Negative 3. All right, so there's negative 3 down below. Okay. Now what do I do with the lines? What should I put here? Dotted, right? All right, the reason I put dotted is because, technically it wouldn't pass the vertical line test. You guys remember that math class? Okay. So when I am looking at this graph and I say, okay, I was going at a constant velocity, right? I was going at a constant velocity of plus 1.5. And then I stopped. Velocity equaled 0. What kind of acceleration is right here? Positive or negative? Because did I speed up or slow down? Yeah. I slowed down. I came to rest. Here, though, is where it gets a little bit tricky. Do you agree a horizontal line means I'm going at a constant velocity because acceleration equals 0? And my constant velocity was negative 3 meters per second. Do I have an acceleration here? Yes. It is a negative acceleration, correct? Is it a negative acceleration because I slowed down? Good. So you got to kind of tweak with your mind a little bit. In math, how we always know that negative 3 is less than 0? It kind of messes with you a little bit because that negative isn't meaning that it's going slower. That negative just means it's traveling at 3 meters per second, but it's traveling at 3 meters per second now in the negative direction. So if I go from 0 to now I have a speed, I sped up, but I sped up in the negative direction, right? Okay, so as we're going through these graphs, really practice just taking it chunk by chunk. So we did this first chunk here, talked it through, and we wrote notes on the graph. Write on it. Put as much info there that you need. Remind yourself it's a positive slope. Then come here, do our horizontal part, and then go ahead, do your negative line right there. Okay? So as you're going through, sometimes students get overwhelmed because they're just looking at it and they're trying to do it in their head. Work through it just like how we did and go step by step and say, okay, well, what's happening to my position? How long did that take? Okay. This graph, I can gain some other information too. What else can I grab from this one? Can I get my total distance? Even though it's a position time graph, could I get my distance? Yeah. What's my total distance? How much did I cover in the first chunk? In the second chunk? And in the third? Good. So my total distance is 30 meters. What's my displacement? 0 meters. Okay, so this took 20 seconds. So speed, distance over time. Take your 30 meters divided by how much time? 20 seconds. Who wants to give me as a decimal? 1.5 meters per second is my average speed over the entire trip. My velocity displacement over time, 0 meters per second, because my displacement was already 0. So I just have to take my 0 divided by 20. Okay? So there's a lot of things that we can get from this. We can even come up with a narrative that says that Miss Baker ran to Target, which was 15 meters away. She stood in line for 10 minutes at Starbucks and then ran home faster, covering the distance in 5 seconds at time. It's really fast at Starbucks at Target. It's really freaky fast. So remember, the graphs actually represent somebody's motion. So when you're asking yourself, okay, well, how do I know what's going on? Ask yourself, well, where did the person start? Make it as a person or a car. Are they moving away from start? Well, they went forward to the 15 meters, and then they stood there, and they came back. Okay? So try to take it step by step, and then that will kind of help you once you solve for slope here. So we solved for slope those 3 times. Then we were able to plot our velocity time graph. Okay? So today you guys are going to do an additional practice. Okay? So with your additional practice, there is a video that goes along with it. So if you're working and you get stuck and you don't want to ask me, you can watch the video. There is tons of extra practice that I also published if you guys want it. This is about day 3/4 of graphing. So what I want to do before we take our big test, I want to do a small quiz, kind of like what we had on Tuesday. Just a small quiz, check in with you, see how you're doing on graphing. So then you can get a few more points in that test category, but then also give you a pretty good idea prior to the test. Do you understand the content or not? So for you guys,